this video, we're doing some advanced simplification of fractions. And the reason that this is going to be an advanced problem is because you may notice right off the bat that we have a fraction within a fraction within a fraction. And when this is the case, when you have fractions inside of other fractions, what you want to do is start from the core, the innermost fraction. You want to start from the inside and work your way out. What we realize here is that we have sort of this outermost fraction, a over this denominator. So that's one fraction, a over the denominator, where the denominator is 1 plus a over 1 plus 1 over x. So this is going to be our outermost layer. Within that, we have this second fraction here, which is a over 1 plus 1 over x. That's going to be the next innermost layer. But then within that, we have this little fraction in the denominator here, this 1 over x. So what we need to do is start from the inside. We need to start with this 1 over x, start our simplification there, and work our way out to this fraction and then to this fraction. So here's what that's going to look like. We have this 1 over x here. That's our innermost fraction. Well, we have 1 plus 1 over x in this denominator. We need to find a common denominator so that we can combine 1 and 1 over x. So if we take this out here, and let's go ahead and write this in a corresponding color, we have 1 plus 1 over x. In order to find a common denominator, we'll need to multiply this 1 here by x over x, because when we do that, we'll get a common denominator with this fraction where the denominator is x. So when we simplify x over x times 1, we get x over x, and then we have plus 1 over x here. Now, because we have a common denominator, we can add these together and we get x plus 1 over x. That means we can go ahead and rewrite our original fraction as a over 1 plus a over x plus 1 over x. So now we have a common denominator. We have a divided by this fraction. We're in this layer now because we're dealing with this whole fraction here. What we need to realize is that this is really a over 1 divided by x plus 1 over x. And of course, when you have a fraction divided by a fraction, you can take the fraction in the denominator, flip it upside down, find the reciprocal, and multiply instead of divide. So this becomes a over 1, and instead of dividing, we'll multiply by whatever we get when we flip this upside down, by the reciprocal. So this becomes x over x plus 1 instead of x plus 1 over x. Now when we multiply our numerators together, we get a times x, which is going to give us ax, and then in the denominator, 1 times the quantity x plus 1, which will of course just be x plus 1. Now we can replace that fraction in our original problem, and what we're left with is a divided by 1 plus, and this fraction we just found replaces this fraction here, so we get ax over x plus 1. Now we're into the denominator here. We need to find a common denominator within our denominator so that we can combine the 1 and the ax over x plus 1. So in order to do that, we're going to multiply this 1 here by x plus 1 over x plus 1 so that we get a common denominator with this fraction. When we multiply x plus 1 over x plus 1 by 1, we're just going to end up with x plus 1 over x plus 1 plus ax over x plus 1. Because we have a common denominator, we can combine these two, and we get x plus 1 plus ax all over x plus 1. Now this value we just found is going to replace our entire denominator right here. So what we're left with is a over x plus 1 plus ax over x plus 1. And now we're really into our last layer here because we're dealing with the fraction as a whole. Just like we did before, we need to realize that this a in the numerator is really like a over 1, and instead of dividing this a by a fraction, we're going to multiply by its reciprocal. So we're going to take this fraction from the denominator and flip it upside down, put x plus 1 in the numerator and x plus 1 plus ax in the denominator. Now when we multiply across the numerators, a times x plus 1, we have to distribute the a, right? The a has to be distributed across the x and the 1 because this is like multiplying a by the binomial x plus 1, so it's a distributive property problem. So a times the quantity x plus 1 is going to be ax plus a. Now in the denominator, we have to distribute 1 across x plus 1 plus ax, but of course 1 won't change the value. So what we're left with, we'll reorder our terms. We'll say ax plus x plus 1. And that's it. That's how we can use a combination of common denominators and this trick where we multiply by the reciprocal instead of dividing by the original fraction to simplify a complex fraction like this one.